Unlocking the mystery. How to derive an equation. Hello, wonderful learners. Today, we're embarking on an exciting journey to understand what it means to derive an equation in the world of mathematics and science. Whether you're a student, a budding scientist, or just curious about how things work, this video is crafted just for you. We'll break down this concept into bite-sized pieces, making it easy and enjoyable to grasp. So, let's dive in and unlock the mysteries together. Before we delve into the process of deriving an equation, it's crucial to understand what an equation is. An equation is a mathematical statement that asserts the equality of two expressions. It serves as a recipe or a blueprint that describes how different variables are related to each other. To derive an equation means to create or discover this mathematical formula by using a combination of known facts, observations, and logical reasoning. It's like being a detective in the world of numbers and symbols, piecing together clues to reveal the hidden truth. Deriving equations is not just a mathematical exercise. It's a fundamental tool that scientists and engineers use to describe the universe. From predicting the trajectory of a space shuttle, to understanding how a virus spreads in a population, equations form the backbone of our scientific understanding. In essence, when you derive an equation, you're building a bridge between theoretical concepts and the real world. It allows us to translate complex phenomena into a language that can be analyzed, understood, and applied. 1. Identify the problem. Start by clearly defining the problem you want to solve. What are you trying to find out? What variables are involved? 2. Gather information. Collect all known information and relevant data about the problem. This includes constants, variables, and previously established equations. 3. Analyze relationships. Look for patterns or relationships between the variables. How do they affect each other? Are they directly or inversely proportional? 4. Formulate a preliminary equation. Based on your analysis, construct an initial equation that captures the relationship between the variables. 5. Refine and test. Verify the accuracy of your equation through testing with known data or by applying logical reasoning. Adjust as necessary until your equation accurately represents the problem. 6. Finalize the equation. Once satisfied, finalize your equation. Congratulations, you've derived an equation. Let's apply what we've learned with a simple example. Imagine you're trying to derive an equation for the distance ddd traveled by a car over time ttt, knowing that it moves at a constant speed sss. By understanding that distance is the product of speed and time, you can derive the equation d equals std equals std equals street. This process can be applied to more complex scenarios in physics, chemistry, biology, and even finance, following the same fundamental steps but incorporating more variables and relationships. And there you have it, friends, a comprehensive guide to understanding and mastering the art of deriving equations. This skill is a powerful key to unlocking a deeper understanding of the world around us and fostering innovation and discovery. We hope this video has illuminated the path for you and sparked a curiosity to explore further. Remember, every equation tells a story, and now you're equipped to uncover those stories on your own. Happy learning, and see you in our next adventure into the wonders of science and mathematics.